Today, we want to introduce this new kind of function. Let's take a look at what this function does. We have for our input just a point in R2. So the input is this point in R2. So this function is going to assign something to each point in R2. Let's take a look at what the output is. The output is a vector. So that's new. We've had functions of two variables before. We've had functions that take inputs as R2, but they have outputs a real number. This function is taking an input from R2, and instead of assigning a height, the way when we thought about it as a height at each point, we're assigning a direction to each point. So this function assigns a direction to each point in R2. Not just a direction, an entire vector. We're not just assigning a number to each point in R2, we're assigning a direction to each point in R2 as well. At each point in R2, we're putting a vector there. This is different than what we had before. A function, a real valued function, just assigns a scalar. Which we thought about as the height. Above the XY plane. So in that situation, we're just thinking of assigning a magnitude to each point in R2. Now, with this function, we're assigning a vector. So instead of thinking of the graph as being a surface where we just have a bunch of heights above every point, at every point we have a vector. So the graphs look very different. The graph is going to be a bunch of vectors. So this is just a vector field. Vector field that I made up, just like saying f of x equals xy equals x squared times y. It's just something that I made up. But to each point in R2, we can figure out what the vector looks like. So if I want the graph of f of 0, 0, that'll be 0i plus 1j. Cruising along the x-axis, f of 1, 0 is 1i plus 1j. So here we are plotting vectors along the x-axis. So if this is the point 0, 0, here at the point 1, 0, I get the point, the vector 1, 1. Here at the point 2, 0, I get the vector 2, 1. If I look in the other direction, I get the vector negative 1, 1. So at each point in the plane, I'm assigning a direction. Notice that this particular vector field only cares about the x value. This vector field only cares about the x value. What's going in the y direction is always just 1j. That's why every vector is just 1 unit tall. So I'm just going to get a copy of this spread of vectors at every y value, because our function doesn't actually care about y. So if I plot some more values. We get an idea of what this vector field looks like. And at every value of x, we get this kind of spread of vectors. It kind of like blows out that way. But it's the same at every x value. And this is the reason that I picked this one to draw. But this is what the graph of this function looks like, where our x-axis is here. And here's our y-axis. At each point, there's a vector, not just a value, a direction, and a magnitude. Any questions? One way to think about a vector field is to think about the water, the stuff flowing around on the surface of the water. At each point, the water is going in some different direction. And then you could think about how things would flow through this vector field. If I took something like a leaf, and this is what the water was doing. I don't know why the water is going like this. But if this is what the water is doing, if I took a leaf and dropped it on the origin, 0, 0, it would start going in this vertical direction. And it looks like since the y value, or since the x value is 0, it's never going to move from side to side. The side-to-side motion, xi, that's always going to be 0 if I take the leaf and put it in the water on the y-axis. So it's just going to cruise up the y-axis. Now, if I take a leaf and put that same leaf, actually that one has left. So I have to grab another leaf. If I grab another leaf and I drop it on at the point 1, 0, it's going to start heading off in this direction at a 45-degree angle. But as soon as it moves off of this point, it's already moving to a little bit to the right. And so it's going to kind of bend a little bit more to the right. It's going to turn to the right a little bit more. Because as x increases, it starts moving more in the x direction. In the y direction, it's steadily moving up. But in the x direction, it's going to move more. It's going to move more in the x direction, because as we get further along with higher values of x, these lines get flatter. So we can imagine a path. I could take the 2 leaves, drop them here. One is going to move directly up. The other one will move off in a curve. Any questions? Now here we have a vector field on R2, a 2-dimensional surface. We could also make a vector field f of x, y, and z, and we can just think of that as air currents in a room. Think about a mote of dust that's not subject to gravity. And we drop that in this room, it's going to fly, it's going to float around as the air pushes it around. That's what we're trying to incorporate. Okay. This kind of function is called a vector field, because at each point we make a vector, so we end up with this field of vectors. How's everybody okay? Can't all be F. Let's take a look at another vector field. One that involves X and Y. And see if we could notice some stuff. Well, this certainly doesn't reveal anything. We've got one vector, it's the 0 vector at the origin. So if I think about this surface, this kind of flow on the surface of the water, if I put a leaf at the origin, nothing is happening. I'm going to follow a similar pattern up here. G of 1, 0 is going to be 0 for Y. So 0I minus 1J. So we get nothing happening at the origin. But the further we go away in the X direction, the more this vector is pointing downward. So I've got like a 0 here. Then 1 unit away, I've got a vector pointing down. 2 units away, I got a vector pointing more down. 3 units away, I'd have a vector pointing even more down. So we're just trying to get an idea about what's going on. If I look at what's going on the other side, so if I keep this Y at 0, I'm going to get no movement on the X. So 0I, but this time it'll be minus a minus 1, so plus 1J. So on this side, I got vectors pointing the other direction. So here we see along the X-axis in this vector field, we can see we're getting some kind of rotation. We can see the X-axis seems to be trying to spin around the origin just by looking at these values here. Spin. Let's see what happens if I look at, if I take this X-axis, or look at all the place where the Y is equal to 1. Go from Y equals 0, where the X-axis, where we're seeing all this spin around the origin. Let's move that up to Y equals 1. So I want to do the same thing up here. I want to find G of 0, 1. So G of 0, 1, in this case, X is 0. So I'm going to have no side-to-side movement, or sorry, X is 0. So 1I plus 0J. So at this point, I'll have 1I plus no J. So it's going just this way. If I look at G of 1, 1, I'll have 1I minus 1J. So at this point, I'll have 1I minus 1J. At the point 2, 1, I will have 1I minus 2J. And at the next point, I'll have 1I minus 3J. If I go in the other direction, I'm going to maintain this 1i because I'm looking at all the points where y is equal to 1. I'm going to maintain this 1i movement, but my j movement is going to go the other direction. So at negative 1, 1, I'll have 1i minus a negative 1j. So it'll kind of be pointing this way. Then at negative 2, I'll have 1i and 2j. Any question? Yeah. Yeah, the vectors are going to be all over, all on top of each other. We saw it, we only saw it happen for the first time here. It didn't happen up here because I separated these out a little bit too far. I put that extra half a box of space. But here, these vectors are crashing into each other. So it becomes very difficult to picture our vector fields. Usually what we're going to do, what we want to do is represent longer vectors, but try to space them out a little bit more so that we could see distinct vectors. We can see just blindly plotting vectors onto a grid, they're going to be all overlapping. Because remember, at each point there is a vector. So even though this vector says, 3 units straight up, as soon as we're 3 units straight up, there's a vector kind of pointing a little bit off to the side because the I component uses the y coordinate. So even if we're up a little bit, there's a vector pointing off that way. So at every single point, there is another vector. There are an uncountable infinity of vectors all over the place. It is a terrible mess. When we are graphing functions, y equals f of x, we could just imagine this continuum of points where we just plot all these heights and they're all distinct. Here, it's a mess. At each point, we have a vector, and vectors take up too much space to draw in a plane. Any questions? So the I vector is the x direction and the j vector is the y direction, but look how I've defined my function. I can put whatever I want, whatever combination of x's and y's I want for the I component, and whatever combination of x's and y's I want for the j component. We can assign separate functions. So as we plot more of these points, that initial assessment of what's going on in the x-axis is being borne out by the additional vectors that were included. It looks like we're getting some kind of circle going around like this. So it looks like if we put a point leaf onto the y-axis, it's going to initially start going just horizontally, but as soon as it moves off the y-axis, it's going to have some x component, so it's going to have some minus x times j, and that's going to cause this swirling effect. Any questions? Is everybody okay? Incorrect. This is very weird. you're not okay. You're only saying that you're okay because it's Friday and you want to leave. And there's less than 15 minutes of class left. No one ever asks questions in the last 10 minutes of class on a Friday. I can get away with whatever I want in the last 10 minutes of class on Friday. We've had exactly 2 examples of this vector field business. It's just a new kind of function. So this is the new kind of function that we're going to play with. But we do need to not just blindly follow our nose and think, and we need to think about what we're going to be doing. So what are we going to be doing with vector fields? Some things that aren't obvious that I've already mentioned. We're going to want to think about the flow of the vector field. To draw my y-axis. Some things that we want to think about. One of the things that we'll want to think about is, like I was talking about, the leaf on the water. What is the flow of this vector field? What would this vector field do to a leaf? We imagine the vector field as the flow of water. The flow of the vector field is just a leaf on the water. The other thing that we're going to want to think about is, what if we're in this vector field and we have another path in mind? So you'll want to think about a path through the vector field. So imagine that there's some water, and instead of just being a leaf on the water flowing with the vector field, let's suppose that we are a boat and we have to go through the water. At some points, the water is going to be pushing against us. At some points, maybe the water is pushing along. So for example, if the water is going perpendicular to my path, then it's just going to be pushing me along to the side. It's not really fighting against my forward motion. It's just pushing me along to the side. But if the water is coming in at a 45-degree angle into my face, some of that vector field is working against my forward progress. So if I'm coming along this way, at this point, some of this vector field is pushing against me. Because if I'm coming directly horizontal at this point here, this vector field is pushing pretty hard. But as I get closer to the y-axis, the vector field stops pushing against me. As I cross the y-axis, now the vector field is pushing me along. Some of the vector field is pushing me in my direction. My vector wants to go this way, and some of the vector field is pushing along in this direction. So I have these 2 vectors. One vector is my path through the vector field. The other vector is the vector field itself. I've got 2 vectors, and I want to know how much of one vector is pushing in the direction of the other vector. What are we talking about? two vectors. How much of one vector is going in the direction of the other vector? What is that? Not a derivative. Although I did use a lot of derivative words because I'd used, what was the derivative word that I kept using there? It's also a vector word. Direction is the derivative word that I kept using, right? That's one of the things that we care about with derivatives. What direction are things headed? We're describing that with vectors. If I've got two vectors, a path through the vector field, here we have a boat in the water. So now I have two vectors. How much of one vector is going in the direction of the other vector? That would be a question that we want to ask too. Any questions? Here's our story of vector field. We got to think about our calculus questions. What do derivatives mean? What do integrals mean? Derivatives talk about direction. Vector fields are describing direction. How are we going to do this? Where are the derivatives going to show up? We're going to have to think about integration. That's our other calculus thing. Integration is multiplication, but one of the factors is continuously variable. We've got to think about the kinds of multiplication that we have when we're dealing with vectors. On our describing stuff side of things, we've got these new things called vector fields. We want to imagine a leaf on the water, just flowing with the water. Or we want to imagine a boat trying to cut a path through the vector field. We want to think about this in terms of derivative stuff and integral stuff. Derivative stuff is our rates of change, our direction, where are things headed. Integral stuff is multiplication, but one of the factors is continuously variable. What kind of multiplications are we going to see here? Any questions? Is everybody okay? Incorrect. You're not okay. I'm deliberately not answering questions because it's Friday. And I guess I like cliffhangers. I don't know why, it's kind of annoying. It's like a typical money grab. Like Empire Strikes Back is one of my favorite parts of Star Wars. It's not a complete movie. It leaves things unresolved. And like, oh, it's part of a trilogy. The first movie stands on its own. The second movie, everybody's favorite, doesn't stand on its own. It just leaves things unresolved. It leaves things unresolved in a way that leads you to believe that these things are supposed to be resolved in this story by these characters. Essentially, Empire Strikes Back says, come back for part 2. I know they think it's a part 3. I know he thinks it's a part 6, but get over yourself. There's A New Hope, the original Star Wars, stands alone. Makes sense. You could retcon the fact that you were thinking about a trilogy of trilogies the whole time, but you knew that after making this movie, there was not a guarantee that you were going to get to make any more of these movies. This is your one shot. I hope it works out. Oh, I get to make more? Okay. It was actually the first part of a trilogy. It's like, oh, no, it wasn't. Empire is a sequel that takes 2 movies to get through. You know what I mean? It's like when Hunger Games, the last Hunger Games movie, so we're going to split it into 2 movies. It's like, oh, that's an obvious money grab. It's like, well, hey, do you like Empire Strikes Back? Yeah, it's my favorite. It's not even a complete movie. You know what I mean? And never mind the fact that the Disney come along and said, we need to squeeze some more money out of this. Remember all that stuff that happened, all that torment that those characters went through? We're going to erase that. The worst thing that Disney did was bring back Luke, Leia, and Han. The worst fucking thing. That is 100% pure fan service. It would be so cool to see Luke, Leia, and Han. Their story is over. Write some new king characters. No. We're going to have the Book of Boba Fett. Son of a bitch. We're going to have the Han Solo story. God damn it. What's the best Star Wars property to come out most recently? The Mandalorian. And why? Original fucking characters. A new story in a familiar universe. Disney, you're terrible at your job. I'm calling you out. Disney, you are bad at your job. And Disney, you're bad at the storytelling part of your job, because Disney is just like, point of order, our job is making money. And we extract shit tons of money out of the populace, so fuck you. That's my Disney voice. That's what Mickey sounds like when he's not in front of people. That's Mickey on a hot mic moment. Oh, okay, I'll see you guys later. Oh, those fucking idiots are gonna give me so much fucking money. Oh. That's where I think South Park got that wrong. Because he was just using his Mickey voice in other scenarios, right? No, it's not Mickey voice all the time. That's the voice that he puts on. That's his public facing voice. Mickey on a hot mic would be like, oh man, I need a bourbon. Goofy, give me a damn drink. So anyway, what are we talking about? Oh yeah, Disney making money. All right. So, like when I heard that Disney bought Star Wars, I was first of all not surprised. Disney's just going to buy everything. And I thought, this could go, and I said, this can go in two ways. They could just use it as a vehicle to extract more money from the public, or they could actually tell a story. And then episode 7 came out, and I thought, well, I see what they're going to do. Actually, I knew that was going to happen once they said they hired J.J. Abrams. Oh, great. We're going to have a storyteller that doesn't know what's going on in his own fucking story. J.J. Abrams, I'm calling you out too. If you don't know what's going on in the mystery box, that's bad. Mystery box is fine for the audience. You need to know what's going on so that you can make a story that makes sense. This is Dungeon Master 101. Come on, man. And lens flare is stupid and you ruined it. All right, that's it for today. That's it for this week. I'll see y'all on Monday. Everybody go watch The Mandalorian and lament the Star Wars stories that we could have had, but Disney needed more money. Have a good weekend. It's a good thing that Disney does not care what I have to say about them. So.